Hello, Miss Winelander here, and I'm going to go through the very first lesson video in Algebra 1A. This is for Unit 2, Lesson 1. So as a reminder, this is the modified plan right here that you're about to follow, and that is where you're going to watch a lesson video, each lesson when it's assigned. I'm going to go through the most important questions from that lesson, usually 3 of them. I'm going to go through how to solve them, ask you to pause and solve one on your own, and do that 3 different times. Those questions that you are solving on your own during the video, that's what you're going to turn in for your sample work at the end of the unit. So it will help you to pause and try on your own to make sure that you're understanding the video and the concepts, and then will also have an impact on your grade when you turn that in for your sample work, which is worth over 10% of your grade. So that's over a full letter grade. So today, we're going to work through Unit 2, Lesson 1 with variables and expressions. So the objective that your lesson gives you in Connexus is to write algebraic expressions. So as a reminder, this is the objective from Connexus. We're going to be following that same idea, but you do not have to do the rest of the lesson in Connexus. This video takes the place of the instruction part because I've provided practice problems within the video. This is your practice problems, and then you'll just go to the end of the video when you finish, and then you'll go to the end of the lesson and take your assessment. So usually a quick check or a quiz or something. So today we're going to be focused on 2 main success criteria. So it's like how are you going to know how you'd be successful on that objective? One's going to be I can translate from word phrases to algebraic expressions. The other is I can translate from algebraic expressions to word phrases. So one way and then the other. So there's some keywords that we're going to be talking about. First one is algebraic expression. So what is that? If you look at the snip from your textbook here, an algebraic expression is a mathematical phrase that includes 1 or more variables. So it could be the variable a, it could be 7b, it could be maybe longer, maybe 3x minus 2z over 7. So it's a mathematical phrase that has 1 or more variables, 1 or more letters in there that represent something. You also have numerical expression. So a numerical expression is a mathematical phrase involving numbers and operation symbols but no variables. So that could be 2 plus 3. We know that's 5, but it's a numerical expression. So again, no variables, no letters in that. Another keyword is quantity. So quantity is anything that can be measured or counted. So some quantities stay the same, and some of them change. So some of them might be listed as variables. So that's that symbol that represents a variable quantity, or some might stay the same always. Just kind of depends on that situation. So now that we have our keywords and essential understanding, let's go through the first question from the video. So this is problem 3 from your textbook, and we're going to be talking about writing expressions with 2 operations. So remember, operations are things like addition, subtraction, multiplication, division, etc., etc. So there's going to be at least 2 of those. So what is an algebraic expression for the word phrase? So A, 3 more than twice a number x. So 3 more than, so more than, that lets me know it's talking about addition. And it's more than what? It's more than twice a number. So twice a number, 2 times a number. What number? Number x. So it's 3 more than twice a number. So 3 plus 2x, or you can write that as 2x plus 3. They both mean the same thing. The next word phrase is 9 less than the quotient of 6 and a number x. So 9 less than, so less than is saying subtraction. It's 9 less than what? The quotient of 6 and a number x. That word quotient is talking about division. So quotient of 6 and a number x. So it always goes kind of first things first. So 6 and a number x, so 6 divided by x. So we're going to start with our 6 divided by x, and it's 9 less than that. We don't start with 9 and then subtract that quotient of 6 in a number, because it says it's less than what? So you have to start with a what first. Now, if quotient's a new word for you, that's all right. It's a word you'll see pop up frequently in mathematics. It represents division. Some other words that you might see. You might see sum for addition. You might see difference for subtraction. These are kind of common ones. Again, that quotient for division. You might see product for multiplication. You'll see some other ones as well, but those are the common ones. So our next part is the product of 4 and the sum of a number x and 7. So the product of 4 and something else. So product numbers talking about multiplication. So the product of 4 and something else. So we have two things that we're taking the product of. So we have 4 times something else. What's that something? That's a sum of a number x and 7. So sum is addition, and we're adding x plus 7. So it's 4 times x plus 7. Now we can't write it just like that because we want to say the product of two things, 4 and x plus 7. It's all together, so that's why you put grouping symbols or parentheses around that. So now that we worked through problem 3 in the video, try question 1 on your own. So pause the video and answer what is an algebraic expression for each word phrase below. So A, B, C, and D. And remember you can use the note sheet that looks just like mine that's attached in the modification over the message board. You can write it on kind of scrap paper that you might have, but put it somewhere where you're going to be able to find it again later, because you need to turn in this problem along with the other ones from this video at the end of the unit in your sample work. All right, well, welcome back. So now we're going to work through problem 4 from the textbook that's using words for an expression. So what word phrase can you use to represent the algebraic expression 3x? So we know it's an algebraic expression because it has a variable. Well, what words are that? Remember, we just wrote down some kind of common ones. So let's think about, well, what is this in math language and kind of translate it to English. So 3x is just like saying 3 times x. So you could say 3 times a number x. Or we learned that other new word that you're going to see popping up a lot in mathematics, that product. So you could also write the product of 3 and a number x. So now pause the video again and try writing these 4. Remember to use those words from up above. So remember that when you see addition, you can use sum. When you see subtraction, you can use difference. When you see division, you can use quotient. See multiplication, say product. Also keep a close eye on, remember when we did 9 less than the quotient of 6 in a number x, to say that you subtract 9 from something else? Keep a close eye on that as well. Make sure you're writing these in the correct order. If you have any questions, you can always ask. So pause the video and try those 4 on your own. Remember, keep track of it because you're going to turn it in at the end of the unit. All right, welcome back again. Now we're going to work through problem 5. So we're going to write a rule to describe a pattern. So in this problem, looks like we got a nice little picture that goes along with it, and it's titled Hobbies. So the table below shows how the height above the floor of a house of cards depends on the number of levels. What is the rule for the height? Give the rule in words and as an algebraic expression. So we got to do 2 different things here. We got to give it in words and algebraic expression. So here's our picture here. We've got some information. Looks like from the floor to the top of the table is 24 inches. Each card is 3.5 inches. Remember, we're looking for the height above the floor of a house of cards, depending on how many levels. So this table kind of helps you figure it out. So they're saying for the number of levels, we're going to have our 24, because that is our set number there. The table's always 24 inches, and we're going to add 3.5, the height of one card, times how many cards do we have? Well, first 2 levels, we have 2 cards, so 2 times 3.5 inches. For the third level, we got to multiply by 3, because now we have to add 3.5 plus 3.5 plus 3.5. For 4, I have to make sure we're keeping track of another 3.5 inches for our card on top. So when you write this out or you look at this table, hopefully you're starting to recognize a pattern. So here I notice that we always add 24. We're always multiplying 3.5 times some number. And the number represents the number of levels in the card. It's always this value here. So that's going to be what we're going to substitute in there. It's our variable, in this case, n. So our rule as an algebraic expression is 3.5n plus 24. All right, and how do we write that in words? Well, we kind of said it out loud as we were going through it. So there's many ways you can use some of the vocabulary that you've been refreshing your brain about in this video. So the product of 3.5 and n and the sum of 24. So you could discuss that. You could say multiply the number of levels by 3.5 and add 24. They're looking for the rule in your own words. There's not just one way to put it. So now that we've answered that whole question there, I want you to try one on your own. So again, make sure that you pause this video and try question 3. This time it's suppose you draw a segment from any one vertex of a regular polygon to the other vertices. A sample for a regular hexagon is shown below. Use the table to find a pattern. What is the rule for the number of non-overlapping triangles formed? Give the rule in words and as an algebraic expression. And they have helped you out with that table, so you can also try to recognize the pattern in the table. If you don't know some of the vocabulary, so that vertex is talking about each of these kind of what some people think of as almost corners, so that's where 2 sides come together. So they're saying you draw a segment from one of these to another vertex. And they don't draw these because that is one of the sides. So pause the video, make sure you write it in words and an algebraic expression. Alright, so we've watched this whole video now. You've answered at least 3 of those questions on your own. Make sure that's in on a safe spot. It's labeled, Algebra 1A, Unit 2, Lesson 1, because you want to make sure you can turn those in at the end of the unit. And let's just do a quick review. So this is our success criteria that we were focusing on in this video. Can you check these off? Can you translate from a word phrase to algebraic expressions yet? If so, yay. If not, rewind the video, try to watch it again, reach out for help. You can check out your textbook, use Khan Academy, find a resource that can help you with that. Same thing with can you translate from algebraic expressions to word phrases? If yes, check. If not, then make sure you go back now and learn how to do that. If there's an exit ticket, this is the direction that you'll follow. You'll type this in, enter your test ID and your student ID. And then remember at the end of this lesson to go to the last page in the Connexus lesson and answer that quick check. You do not have to do the instruction piece of Connexus. That's what this was. This was your instruction. Thanks for watching this first modified plan video. I will see you in the next lesson.